All right, today's lesson is 9.7 on probability. So you guys probably know a little bit about probability. Simple probability is called simple probability because it's not too complicated. So for example, what's the probability of rolling a tail or flipping a tails on a coin? So there are two choices, heads and tails. If you want to flip tails, that'd be one out of the two choices. So for simple probability, you know that this is what you want or the desired outcome is up top. So the way I say that is favorable over your total number of outcomes. So on a coin, two outcomes are total. When you roll a die, there's six, and all kinds of different things from there, okay? So it gets a little bit more complicated when we're talking about, rolling more than one die, trying to get a sum. But the first part is going to be fairly straightforward, and then we're going to get into some fairly complicated stuff. A little bit about the notation. Standard notation for probability is P of E. The E stands for an event. So P of E, probability of an event occurring. Odds are the ratio of the favorable to the failures. So odds are a little bit different than probability, but you guys are going to see there is a relationship there. Notation for odds is O of E, so odds of the event. And sometimes we want to say odds of the event not happening. So for example, if I ask for the odds of like rolling a 1 on a die, I can say, what are the odds of 1 prime? That prime right there means what are the odds of not rolling a 1? So the prime means not. And you guys may see that on your homework or in different places in the book. So we can get to that when we come to it. So it says, first example, you're going to have a bunch of these for your homework. Find a probability and odds of rolling a 4 on a die. So first, how many 4s are there? There are 1, so the probability of the event or rolling a 4. Some people have probability of 4. Okay, either way, probability of the event. There is 1 4 on the die, so it's 1 out of total number is 6. Okay, the way you think about odds, so odds of the same event, how many successes are there? So a success would be a rolling a 4, so that would be 1. Okay, and we usually don't write it as a fraction. We write it with semicolon here. So actually colon. So it would be 1 to how many failures? So if there's 6 total numbers on a die, 5 of those would be failures. Okay, 4 would be a success, and the other 5 would be a failure. So there is a relationship between odds and probability. If you add these two numbers together, you can see that you get the total. So the successes plus failures, that would be your total amount. So that's kind of a good way to check if your odds are correct. So find the probability and odds of not rolling a 4. So this would be probability of not the event. Just like I said earlier, that prime means not. So find the probability of not rolling a 4. How many are 4s? There's 1 of them. So how many is not a 4? That'd be 5 out of the total, which is 6. For the odds of the event not happening. So how many successes are there? That would be 5 successes. And how many failures are there? That would be 1 failure. The failure would be rolling a 4 because you would want to not roll a 4. So 5 of them are not 4. 1 of them is 4, so 4 is a failure in that case. Next one, find the probability and odds of rolling an even number on a die. I'm going to have you guys pause the video right here. Go ahead and calculate and write down the fraction and the ratio for finding the probability and odds of rolling an even number on a die, and then press play when you're ready. Remember to always simplify fractions and simplify ratios. Okay, so probability of rolling an even number. How many even numbers are on a die? 2, 4, 6. So that would give you 3. So the probability of the event happening would be 3 out of 6 total, which is 1/2. Always reduce. Same thing with odds. Okay, so odds of an event. How many successes are there? So 2, 4, 6 would be considered a success. So there are 3 of them. And how many failures? Failures, let's see, probability and odds of rolling an even number. Failures would be 1, 3, and 5. So that's 3 of them. So a ratio of 3 to 3, that simplifies to 1 to 1 because 3 comes out of both of them. So if you guys ever see odds that are 1-to-1 odds, that means you have a 50-50 chance if you want to talk about probabilities. You have an even chance of getting one or the other. Okay, so then moving on to something a little bit more technical here, mutually exclusive events. And these keywords are really important. So it's designated by or. You definitely want to write that down, highlight it in your notes, okay? So mutually exclusive events, usually designated by or, are events that cannot occur at the same time. And you're going to add the number of ways that events can occur. So we're going to deal with cards here. And so the first example with cards is coming up. You guys listen, depending on how much you played cards when you were a kid, some people may know a lot about cards, a deck of cards, and some people may know little to nothing. It is important to learn about them for this particular section and for the test. So you have to know how many face cards there are, okay? You have to know how many queens there are. You have to know how many tens there are. You have to know how many spades there are. You have to know how many total cards there are. That's important too, okay? So all of those things are important, and you can take the time right now to go look that stuff up. Just look at a picture of a deck of cards and kind of find how many jacks are there, how many aces are there, how many hearts are there, how many are red, how many are black, things like that. And we'll be kind of talking about that throughout here. So find the probability of picking a jack or a queen. So first thing when I read this is I see that keyword or. That indicates that this may be mutually exclusive. So then you have to ask yourself, well, can these two things happen at the same time? Can you have a jack that's a queen? And that's no. That's different than saying like a red jack. Can a jack be red? Yes, there are two red jacks. Jack of diamonds and jack of hearts are red. But there is no jack that's a queen. So in order to do this, you want to find the probabilities of each, and you add the number of ways it happens, okay? So find the probability of picking a jack. How many jacks are there? There are 4 out of the total of 52 cards. How many queens are there? Same thing, 4 out of 52. Now you could reduce those right now, or you could wait till the end. I usually wait till the end. That's 8 out of 52. Make sure you do not add those denominators, okay? And then you reduce to 2 out of 13. So that would be your fractional answer. Usually I ask it as a fraction. If you want to calculate it a percent, it's approximately 15%. And you would do 2 divided by 13 and then change it to a percent. Mutually inclusive events, usually designated by or again. So these are events that cannot occur, can occur, at the same time. So the difference is mutually exclusive cannot, mutually inclusive can. And again, you guys are looking for the word or, so you're looking for the same word. What you're going to do is you're going to add the number of ways the events can occur, and then you subtract the overlap. It means how many ways do both of those things happen at the same time. So a good example is find the probability of picking a spade or an ace from a deck of cards. First thing is circle a keyword or. This tells us that it's mutually inclusive or exclusive. And then you look, are there any spades that are aces? Okay. So there are 13 spades, and one of those spades is an ace. So I'm going to have to subtract that out. So let's find them each separately. Spades, there's 13 out of 52. And then I'm going to add the number of aces, which are 4 out of 52. And if you guys think about why we're subtracting one out, I just double counted the ace of spades. I counted it as a spade. It's one of the 13 spades. And I counted it as an ace also. So you double counted the ace of spades. So I have to subtract the overlap. How many aces of spades are there? There's 1. And that makes sense because I double counted it. So I want to subtract 1 out. And that gives you 16 out of 52, which is 4 out of 13. Okay, so that's your probability right there. If you want to write it as a decimal, it's approximately 31%. Okay, independent events designated by and or then, where occurrence of one event does not influence the other, and you're going to multiply the probabilities. So you guys, if you guys go to Vegas ever, they're really good at kind of manipulating people's perspectives of probability. What I mean by that is there's an interesting game called roulette, and it's where you put a marble on a table and you spin, and you can bet on all kinds of different things. But what they do is they put all the past numbers for the last 10 numbers up there. And so here's how people trick themselves. Every single time that roulette wheel spins, it's an independent event. The last, whatever it landed on last time, does not affect what it's going to land on next time. Okay, so for example, let's just take a really easy one like black or red. Okay, they have black, red, and green, but most of them are black and red. So if you see 5 black numbers in a row, 1, 2, 3, 4, 5, somebody might be walking by and they're like, oh, 5 black numbers just hit in a row. The next one has to be a red. There's a bigger probability that it's going to be red because 5 black numbers just came up. And that is absolutely not true. Okay, it's close to 50-50. It's not exactly 50-50 for that one. But you have the same chance as you did the roll before and the next roll of getting black or red. Okay, it does not matter that you just had 5 in a row or 50 in a row. The next one has no greater probability of being red. And so that's how some people get themselves into trouble because they don't understand independent events. Okay, so in word problems designated by and or then, so if we read the first one, find the probability of rolling a 3 on a die and, so it's either an and or a then, you're going to do something else. If I roll a 3 on a die, does it have any effect on flipping a tail on a coin? Not one bit. Okay, so what would have an effect is if I picked, marbles out of a bag without replacement, that would have an effect on the next thing. But this one does not. So you're going to find both probabilities and multiply them together. Probability of rolling a 3 on a die is 1 out of 6 total. Flipping a tail on a coin is 1 out of 2 total. So that gives us 1 out of 12 for doing both. Okay. Next. Okay, we're going to talk about poker hands here. So a couple things. Again, you guys, some people don't have a ton of experience with cards. I try to put it in a way where you don't necessarily need to know a lot about cards, but you do need to know some of the basics, okay? The hard thing is figuring out how to account for the hand, okay? And so we're going to talk about that now. So how many ways can a pair be dealt in a 5-card hand of poker? First of all, you need to know what a pair is. So say that I am dealt 2, 2, and then Jack, Queen, King. That right there would be a pair. Okay, so the 2s could be anything. It could be 8s, so a pair of 8s, a pair of Jacks, whatever. Okay, but the idea is 2 of the cards are the same and 3 of the cards are different. And so when I want to find out how many ways that can happen, you need to account for that happening. So how do I account for being a pair? So first of all, I need 2 of the same cards. So if you think about a deck of cards, there's 13 different types. If I list them all out, it'd be ace, 2, 3, 4, 5, all the way down to king, okay? So if I list all those out, there's 13, and I'm going to pick one of those types. So it's going to be 13, choose 1, okay? Next, I want 2 of those 4 cards. So now I have selected whatever number. In this case, I'm going to select the 2s. And you guys should know that there are 4 2s. Okay, so 2 of hearts, 2 of diamonds, 2 of spades, 2 of clubs. There are 4 of them. Okay, out of those 4 cards, I need 2 of them. So I've selected my pair, which is 2s. I need to now select 2 of those. So out of the 4, I'm going to choose 2. Okay, and now it's kind of tricky because I have to account for these other 3 cards here. Okay, so there's 13 total cards here. I've picked 1, so there are 12 remaining. So I can pick any of the 12, but they can't be the same. So I need 3 different ones out of those 12. So it's going to be 3, choose 12. Okay. And then each of those 3 cards have, so Jack, Queen, King. Jack, Queen, King would be here, here, and here. And remember that I have 4 of each type. So Jack, 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 Jack. Each of those can be picked in 4 different ways. So I can have this Jack, I can have that Jack, this Jack, or that Jack. Okay, so I'm going to multiply it by 4 times 4 times 4. Okay, because there's 4 Jacks, 4 Queens, and 4 Kings. So that right there is a super tricky thing to do. You need to look at the overall hand and you need to start breaking it down by what's unique. So to kind of recap, out of all the 13 types of cards, I'm going to pick 1 that I want a pair of. So that's 13, choose 1. Out of those cards, now that I've selected that 1 type, in this case it's 2s, there are 4 2s and I want to have 2 of them because I need a pair. So that's where your 4 choose 2 comes from. Now, to make so I have this accounted for. I have the 2 2s accounted for, so I'm good with the 2s. Now the rest of the hand consists of 3 other cards. those three other cards can't be the same. So I can't choose like a jack, jack, and a queen because that would be a different hand. You have to choose 3 different cards from the remaining 12. So that's where this comes from. And each of those 3 cards has 4 that make up that type. So that's where you get your 4 times 4 times 4. Plug that in your calculator and you get 1,098,240. Okay, so this actually is written at the bottom of this slide, but I'm just going to say it now, that if you want the total number of hands, actually, let's go down and do it right there. To calculate the probability of 5 different cards, how many total hands are there? There are 2.5 million. Okay, so that's why a pair is such a weak hand in poker, is because out of the 2.5 or 2.6 million different types of hands, you get a pair over a million times. So it's not quite half the probability, but it's almost there. So about half of the time you're being dealt 5 cards, 2 of them are going to match. That's basically what that says. Okay, so that's why it's a weak hand in poker. The fewer the number of hands, the number of ways it can happen, the stronger the hand. And you guys will know that if you play poker. Okay, so how many different ways can a flush be dealt in 5-card poker? So what is a flush? A flush means it's all of the same suit. So same suit means like it's all ace, all hearts. Okay. So how many hearts are there? There's ace, 2, 3, 4, ... So there are 13 total in that suit. So there's 13 hearts, 13 diamonds, 13 spades, and 13 clubs. I want 5. All 5 have to match. Okay. So in order to be dealt a flush, what we're going to do is we're going to pick one of the 4 suits. So we have hearts, we have diamonds, we have, I can't draw real well, but spades, that's a horrible spade, and clubs, probably just as bad. Okay, so we have 4 different types of suits. So out of the 4, I'm going to choose 1. Let's say I choose hearts, okay, just for the example. Okay, there are 13 hearts. So out of the 4, I've chosen 1 type, and now out of the 13 here, I need to be dealt 5. So it's going to be multiplied by 13, choose 5. Okay, and that right there is the total number of flushes, which is 5, 1, 4, 8. Okay, so that's why a flush is a much stronger hand in poker, is because it only happens 5,000 times out of the 2.6 million different times you can be dealt a 5-card hand. Okay. So you guys, listen, I know this stuff is definitely tricky. You're going to have some of the practice on the homework. And if you just type in what the question is into Google, it'll give you a lot of different ways to think about it, a lot of ways to do it. Usually I break it down by types. How do you build the hand by certain types? And those types have their each have their own combination usually, okay? And that's that, okay? So go ahead and give it the homework a shot and look it up on Google if you run into one that confuses you, and we'll go from there. So that's it for probability.